Hello, this is the third video in the series on electromagnetism for classes 6 to 10, and it is meant to be used by students of class 10. In this video, we are going to learn about electric current and some simple circuits. So we use electricity to do all our heavy work, grinding grains, lifting water to a height, and everything else. So electricity is generated at an electric power plant, and it reaches our homes on power lines, which are wires, thick wires, which are arranged on supports. So there's a lot of science and technology involved in generating and delivering electricity to our homes. We will learn some of it here. To understand how electricity works, we need a source. So we are going to use a very convenient source of electricity, which is an electric cell. We can connect more than one cell, a collection of cells, and make a battery. So we are not following the historic journey of the study of electricity here because we are using an electric cell. So historically, scientists took a different path, which some of it we will see later. So these are the various kinds of cells we see. And one simple use of an electric cell is in a torchlight. Every one of us has used a torchlight. So when a switch is pressed on, then the light bulb glows. So this is a basic torchlight. Torchlight is just a light bulb which is connected through connecting wires to a cell. So from the cell has two terminals, two ends, and from one end of the cell, we connect a connecting wire, which is made of metal, usually steel, and covered with covered in plastic. So that the wire is connected to one terminal of the bulb, and from the other terminal, you have a wire going back to the battery. So this is how we connect a bulb to the cell and make the bulb glow. So a cell has two terminals which are marked as plus and minus. Plus is the positive terminal, minus is the negative terminal. And electric current flows from the positive to the negative terminal, and it flows through the bulb. So when an electric current flows, the bulb glows. So we connect we connect the wire to the positive terminal and complete this path. The path goes from the positive terminal through the bulb and to the negative terminal. Only then does the bulb glow. If we connect the terminal back to itself through the bulb, then the bulb does not glow. There is no flow of electricity. So this is here we can see the electric terminals close up, and we wind the wire around the positive terminal where there's a cap and then secure it with a tape. Now we have a light bulb, and we can see the terminals of the light bulb. So there are many thin wires inside, which are called filaments, which are connected to those two terminals. And these are the two terminals, one here and the other one, the bright spot there, which are separated by the dark waxy substance. So this is another smaller bulb. Again, you can see the two terminals, and we have connected the wires to these two terminals. So there is one wire attached to the small shiny knob, and the other wire is attached to this larger cup. So these are the two terminals of the electric bulb. So this is the path. We have drawn the path of electricity from the positive terminal to the negative terminal through the connecting wire, and it's passing through the electric bulb. So when this path is complete and closed, we say it's a closed circuit and current flows through it. And when there's a gap in that path, then there is no flow of electricity and the bulb does not glow. So let us use this to study a few things. We will make a circuit like this with a gap, then close this gap with various materials and see when the electric current flows. So if the current flows and the bulb glows, that means that material which we have used to close the gap allows electric current to pass through it. Here we have a few cells that are connected to the bulb, and the bulb is connected back to the negative terminal, and there's a gap in the connection. So those two iron nails are used to create the gap. And now we have a aluminum wire. I'm going to close that gap with using a piece of aluminum wire and check if the bulb glows. So when I touch these two nails, the gap is closed and the bulb glows. So that means aluminum allows electric current to pass through. It's a conductor. Now we try a plastic straw. The bulb does not glow. So plastic does not allow electricity to pass through it. It is not a conductor, it's an insulator. The stainless steel spoon allows current to pass through. Stainless steel is a conductor. Now, let us check this for this particular material. This is a pencil whose I have exposed the lead of the pencil on both ends. So that lead of the pencil is made mainly of a material called graphite, which is a form of carbon. So now let us check if graphite allows electricity to pass through. So I'm winding the wire on one end of the pencil, the lead of the pencil, and then completing the circuit. And I find that the bulb glows. So which tells us that graphite is a conductor. It allows electricity to flow. So there is a list of materials which allow the flow of current, electric current, and they are called as conductors, iron, steel. So most metals and graphite, they are conductors. And materials like paper, plastic, rubber, wood, glass, they do not allow electric current to flow. They are insulators. So now we can look at the diagram of the torchlight again. So the switch keeps the circuit open. When you push it forward, it closes the gap and allows the current to flow. The electric bulb that we have used was invented by Thomas Alva Edison around 1880. And it was an important event because it created an everyday use for electricity for the common people. Before that, mostly it was the scientists who were studying and playing around with electricity. So this is called as an incandescent bulb. So the bulbs that we use these days are different, but it will take a long time for you to understand the working of those new bulbs. But this Thomas Edison's bulb is easy to understand. He was a great inventor, and he invented many other devices. So this is how an electric bulb looks like. These are the parts. So there are two terminals here which are made of metal. They're separated by this black insulating material. So that there is no contact between these two terminals, no direct contact. So there is a wire here which is fixed, which is attached to the one of the terminals all the way up to the terminal. And then between these two wires, there is a thin coiled wire, which we call as the filament. Filament is made of a metal called tungsten. Tungsten is a metal which becomes hot, gets heated when you pass electric current. So most materials which conduct electricity, they become heated when electricity flows through it. So electricity has a heating effect. Then there's a glass cover, there's a glass casing, and the air inside the glass casing has been sucked out and a vacuum is created, so that it gives a long life to the bulb. So when the bulb burns off, when it stops working, usually the filament is broken. Filament is a very delicate, very thin wire. So sometimes it breaks. So when it breaks, then there's a gap in the circuit and the current does not flow, the bulb does not glow. So let us see what is inside an electric bulb and how we can connect. Let us see what is inside an electric cell and let us see how you can connect the cells. So this is the inside of an electric cell. You can see there is a carbon rod. This is a carbon rod. Every cell has two metal electrodes, conducting electrodes. So this is a carbon rod, and we have seen graphite, which is a form of carbon, is a conductor. So this is one of the electrodes. Then the container, the cup, is made of zinc metal. So that is the other electrode, and between them we have the electrolyte, which is in the form of a paste. So these two terminals of the cell, that is the cap here is connected directly to the carbon rod and the zinc container. These two are separated by this plastic cup that is in between. Prevents direct contact. So here you can see the red plastic cup, which is keeping these the positive terminal and the negative terminal, which is the outside container. They're separated by the plastic cup. So here you can see the line diagram. Here we have the container, zinc container, which is one terminal. The lower end of it, we use it as one terminal. There's an insulator which separates the carbon rod and the zinc container. And there's the electrolyte here is ammonium chloride paste. So this is called as a dry cell. We also have wet cells, and we will learn about how they work later. So a cell converts electrochemical energy. There are chemical reactions going on between the electrodes and the electrolyte, and that is how electricity is generated. So when we use more than one cell, how do we use multiple cells? So one cell is enough to make the bulb glow. But what happens if you use more and more cells? How do we connect them? Okay. So when we create a battery by joining cells, we can connect it in two different ways. So when they're connected like this, we call it as a series connection. So in a series connection, so the negative terminal of the cell is connected to the positive terminal of the cell behind it. And you can connect any number of cells like this. And the positive terminal of the first cell is used as the positive terminal for to connect to the bulb. And the negative terminal of the last cell is used as the actual negative terminal. So we start with the single cell and we connect the bulb glows. So now I add a second cell in series and make the bulb glow. So we can notice that the bulb glows a little brighter. Brightness has increased. We add a third cell and the bulb glows even brighter. And the fourth cell makes it glow even more brighter. So why does the bulb glow brighter and brighter as you keep adding cells? So we know that, or you will understand in some point, you would have understood that this electric cell provides energy. It provides energy in the form of the electric current. So we need that energy to make the bulb glow. So when we use one cell, we have some amount of energy. When we add cells, then there is more energy available for the bulb. So a higher current flows, electric current increases, and the bulb glows brighter. So this is a cell holder. You can fix two cells in this holder. So the springs keep the cell in place without any movement. So there are two lead wires coming out, a red wire and a black wire. So the red wire is the positive terminal of this series, of the entire series, and the black wire is the negative terminal of the entire series. You can also connect the cells in a parallel connection. So this is a parallel connection. All positive terminals of the cells are connected together. All negative terminals of the cells are connected together. And we then feed those two terminals to those two ends to the bulb. So here we have one cell connected to the bulb. Now we added a second cell in parallel. And a third cell in parallel. So here we notice that as we add cells, the intensity of the light has not increased. So we have multiple cells, but the bulb continues to glow the same amount. So in this case, it means that the multiple cells, the many cells, each of them contributes some energy to the bulb. So in this case, as you have more and more cells, the contribution of each cell becomes smaller. So if you just leave this arrangement for a long time, eventually, of course, the batteries will get consumed. The energy will be exhausted and the bulb stops. But it will take a longer time to happen because you have more number of energy sources. Can we connect bulbs also? When we connect multiple bulbs, we can connect them in series or in parallel. So here, this is how we connect many bulbs in series. So what happens if one of them stops working? So the filament breaks, and then there's a gap in the circuit. So if one of the bulbs stops working, then the entire series will stop working because there is no flow of electric current. We have one bulb glowing here. Then we add a second bulb. So the intensity of the light has slightly decreased. And we add another third bulb, then definitely you can see that the bulbs have become dim. So why is that so? Because as we add more, each bulb consumes a certain amount of energy. And if you add more and more bulbs, the energy consumed increases. So the load on the batteries on the battery increases, the current decreases. So and so the bulbs become fainter. We can also connect bulbs in parallel like this. So we have been drawing the diagrams for our electric circuits. A circuit is nothing but a closed path for the electric current. So instead of drawing the various parts of the circuit each time, it is more convenient to use some standard symbols to represent the parts. So here below I have an actual diagram, and at the top I have a diagram that uses standard set of symbols. So what are the standard set of symbols? So here we have the symbol for a cell. So we do not need this plus and minus signs anymore. These two vertical lines together, they represent a cell. So the longer of them is the positive terminal, shorter line is the negative terminal, and the other lines are the connecting wires. So I have here two cells in series, three cells in series in the standard, using standard symbols. So this is how we show a switch, a symbol for a switch, a symbol for a bulb. So I have here a diagram, a circuit diagram using standard symbols. It shows you two cells connected in parallel, two bulbs connected in series, and one switch. So if you're given any circuit diagram, no matter how complicated, you can look at the diagram and make the connections. Okay. So what about the power connection at home? Is it parallel, series, and so on? So power comes to our home on two wires called the mains. We can think of, just like we have two terminals on a cell. So there are these two power lines coming in. So all the devices we have are connected more or less like this, more or less in parallel. Why? Because we know that if the devices are connected in series, just like the bulbs were connected in series, if one of them stops working, then the circuit will break and the other device also will stop working. So that is why we connect the devices in parallel. Okay, so we have learned that cells can be connected in series or in parallel, and we can use standard symbols to represent a cell or a wire or various parts of a circuit.